sklearn, model selection, HalvingGridSearchCV. Description: HalvingGridSearchCV is a strategy for hyperparameter optimization that starts with a large set of hyperparameter combinations and progressively reduces the number of combinations based on performance of the model on a validation set. This approach is particularly useful for large search spaces or when computational resources are limited. Inputs: estimator, a scikit-learn estimator object. This is the machine learning model that you want to tune. ParamGrid, a dictionary of hyperparameter values to search over. Each key corresponds to a hyperparameter of the estimator, and the value is a sequence of values to try. Factor, the factor by which the number of candidates is reduced at each iteration. For example, if factor 2, the number of candidates is halved at each iteration. Resource, the resource to use for the HalvingGridSearchCV. It can be n samples or n resources. N samples refers to the number of samples used to evaluate the performance of the model. N resources refers to a specific resource like time or memory. Resources strategy, the strategy to use for allocating resources. It can be quantile, uniform, or percentile. Quantile refers to a fixed quantile of resources to be allocated. Uniform refers to allocating equal resources across all candidates. Percentile refers to allocating a fixed percentile of resources based on performance of previous runs. Outputs: best estimator, the estimator that achieved the best performance on the validation set. Best params, the best hyperparameter combination found during the search. Best score, the best score achieved by the best estimator on the validation set. Steps: initialize the search with a large number of hyperparameter combinations. Train the estimator on a subset of the data using each hyperparameter combination. Evaluate the performance of each estimator on a validation set. Reduce the number of hyperparameter combinations by a factor of factor based on the performance of the estimators. Repeat steps 2 to 4 until a single hyperparameter combination remains. Metrics: validation score, the score achieved by the estimator on the validation set. Training score, the score achieved by the estimator on the training set. Visualization plots: performance curve, a plot showing the performance of the estimator on the validation set at each iteration of the search. Fine-tune parameters: factor, the factor by which the number of candidates is reduced at each iteration. Resource, the resource to use for the HalvingGridSearchCV. Resource strategy, the strategy to use for allocating resources. Min resources, the minimum number of resources to use for each candidate. Aggressive elimination, whether to aggressively eliminate candidates that perform poorly. Challenges and fixes. Challenge 1: overfitting to the validation set. Sample use case: if the validation set is too small or too similar to the training set, the model may overfit to the validation set and not generalize well to unseen data. Fixes: increase the size of the validation set. Use cross-validation to evaluate the model on multiple folds of the data. Challenge 2: computational cost. Sample use case: if the search space is large, the HalvingGridSearchCV can be computationally expensive. Fixes: reduce the size of the search space by manually eliminating hyperparameters that are unlikely to be optimal. Use a smaller factor to reduce the number of candidates more slowly. Use a more efficient estimator, such as a decision tree or a linear model. Challenge 3: lack of resources. Sample use case: if the resources are limited for each candidate, the search process might not be exhaustive. Fixes: use a smaller search space. Use a more efficient estimator. Increase the resources allocated to each candidate. Challenge 4: uneven resource allocation. Sample use case: if the resource strategy is not optimal, the resources might not be allocated effectively. Fixes: use a different resource strategy, such as quantile or percentile. Experiment with different resource allocation strategies to see which one performs best.